fatigue strength. Okay, we more concerned about the endurance limit. This subsequently what I have done, I will be talking about is qualitatively explaining. So one has to have an idea as an engineer. We should know if this is happened, what the trend will be going to increase or decreasing. The way we know very well, tensile residual stress will increase the life. Detrimental effect to the fatigue life. Compressive. Similarly, there are different processes which I will go through that. Each will have its own effect, which is when a component undergoes such process in the process of making a component from the material. The factors effect is material effect, size effect again, machining quality effect, chemical treatment effect, technology process effect, and assembly process effect. So now I am giving the comparison here. This y-axis is showing as a ratio, normalized, and your x-axis is showing different material. You have aluminum, you have 2000 series, 7000 series, titanium, aluminum, vanadium, then steel. So here how it has to be interpreted, whether you take a geometry for the testing of fatigue cycle with a high strength or incolored 7 watt, you will get some number of cycles, right? Loading is constant amplitude loading, certain stress amplitude, and you do it. Geometry also same specimen level, but in other case geometry is same, loading is same, but different material. It can be titanium, aluminum, cylinder. So when you do titanium, the result what you get with the high strength steel, same geometry is replaced by titanium, will come down by 31% less life. Okay, it will reduce by 70%. In aluminum things, it will come down to 60. How much? 40 thing as no 30 40. Yeah. So it is come down that, and there is a lot of difference between 7000. But the fact that why you are using aluminum alloy, because as you know, titanium alloy is very good resistant fatigue, but is machining is a problem, very expensive, and strength by weight is more compared to aluminum alloy. So still but some cases they use. If somebody has A350, the pack, they are also into manufacturing. They are done for A350 landing gear attachment. It's massive. 10 some few cages, not 1 or 2 cages, few cages made of titanium alloy. Now machining, see, this is what I was telling you, the skin pocket. You do using ordinary mechanical milling can be done, but that's very hard. If a small piece is fine. When you're talking about skin pocket, I mean sheet of meter, so many meters length, so many meters weight, and you have to do specific regions for skin pocket. And pad, there is a terminal is called the pad, where you fasten the frame and stiffener, but in between you have to reduce the thickness. The sheet is a 2 mm, but you need to is sufficient to have a 1.2 mm in the skin pocket. You have to reduce from 2 mm to 0.2, means 0.8 mm you have to do. So you have to do chemical. One can do machine milling, but usually people use chemical milling, one high quality and low quality, some the 100-degree thing. But this is see here. Mechanical milling, if you take as a standard for the given material, is just say some life is giving 1. But if you use chemical milling, it's reducing here. Now if you use mechanical milling but short peening, your life is increasing. Anything more than 1, factor 1 is a beneficial effect. It is increased by almost close to 11%, 15%. Then surface finish, you have already seen rough and polish. Rough will have, because fatigue is a surface phenomenon, depending on the surface condition. If raw means crack will initiate early, so also life with the polish will have better. That's a when they generate Asian curve using mirror polish, they would use that to be consistent. Then size effect also we have seen, not only it affects endurance limit, also your fatigue, because the larger size of the part, the lower its fatigue strength, because when it's subject to the cyclic load, the number of the volume is more coming under the maximum load, so that will affect life. The fact can be explained mainly by the volume of material stress. The larger this volume, the greater the possibility of coming across melted. You are talking metallurgical defect like porosity, interstitial elements and all. So in general, fatigue damage first appears on the surface of the parts. Obviously, that's known. The crack starts from thing. Taking the two following aspects into the improve the fatigue strength, like surface macrogeometric aspect. So poor machining gives a surface roughness that increase the local stress level. Initiation of crack surface is therefore delayed when roughness is low. So in chemical meaning, when they do it, using hydraulic acetate or acidity thing, obviously the surface become, I think one of the slide I will show that, become more rough and rough. So after that they do the cladding. So that the sheet material, if you see to the is a clad and clad. Generally clad it comes from the factory, the clad one, to prevent the corrosion. But once you do the machining or the chemical cleaning, the clad is gone. So it is exposed to the very rough thing. So to minimize that, they do the anodizing, the cladding using some chemical. It's not painting; it has to be done from chemical process. Residual stress aspect, obviously, we have seen tensile residual stress induces any process that induces residual tensile residual is determined right. And I don't know whether you people are aware, when sometimes when small machine is component is machined, they put it in the secker to sec table to sec it up, because in the process of machining it will be inducing the tensile stress. The purpose of secking it at high frequencies to set off those residual stress. That's one of the process they do it. This is chemical treatment. So this is non-treated, you have some life. Okay. But if you do aldehyde, I think this is the terminology used by Airbus. They use a different type of phosphoric acid anodizing, chromic acid anodizing, sulfuric acid. So there's no difference. You see, the chemical is eating away the surface condition. It becomes sulfuric acid became more rough and rough. So life will decrease.